Okay, and so I wanted to put this problem in its own tutorial because it's a really good problem and it involves, well, a bunch of stuff. This is the problem. Express the sine of 3x in terms of just sine of 1x. So this is like a triple angle. And the first thing that some people think of is, the sine of 3x, I can write that as the sine of x plus x plus x. And that absolutely is true. Unfortunately, it does not help. There is no triple angle identity, or at least not that I know of. There is no triple angle, so that doesn't really help us. What we can rewrite it as is the sine of two things added up. So the best way to start this is to see this as the sine of 2x plus 1x, or 1x plus 2x. But that's where we're going to start. And then we have the sine of a sum. And using our previous sine of a sum identity, we can split that up into the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. That's just expanding using our sine of a sum. Expand. Okay. So there's a couple reasons why this is not, of course, the answer. One reason is because I still see some cosine things, and another reason is because I still see a double angle with my sine, and I want only sine of 1x. So we still have some work to do. What I'm going to do next is replace the sine of 2x with its double angle identity. The sine of 2x is equal to the 2 sine x cosine x. And then I'm gonna rewrite. I'm gonna try to color code here, and then the cosine x that was already there, and then plus. I'm going to also replace the cosine of 2x with its double angle identity. Now there actually are three names, remember, and since my directions say I only want sines, I'm going to use the name for this that only involves the sine, and that is minus 2 sine squared x. And then I still have this other sign, oops, excuse me, this other sign that is still there. So I replaced my double angle identities with what they're equal to, and there we are. Okay, let's see what we've got. Now we still have these cosines. These can't be here, but I do know that cosine times cosine is cosine squared, so that's nice. In fact, I'm going to do that next. So this is 2 sine x, and then these guys come together to make cosine squared. And, while I'm at it, might as well distribute this here and here to get rid of these parentheses. So sine times 1 is just sine. And sine times negative 2 sine squared would be negative 2 sine cubed. There's only one thing left that is messing this up, and it's this cosine squared. Remember, I only want sines. So it looks like we're going to be using a Pythagorean and replacing cosine squared with its Pythagorean. So I've got 2 sine x, and then this will be 1 minus sine squared. We've used that one plenty of times. And then plus sine x minus 2 sine cubed x. Nothing's changing over there. And then let's do one last distribution. This times this and this times this. 2 sine times 1 is 2 sine. 2 sine times negative sine squared is negative 2 sine cubed. And then these terms again. This is not breaking any of the rules. This actually is a version of the answer. We just have some like terms that we can get together. 2 sines plus 1 sine make 3 sines. So 3 sine x. And negative 2 sine cubed, take away another 2 sine cubed, makes negative 4 sine cubed x. That is a good looking problem. Understand that everything was supposed to be in terms of sine, and there it is, sine of x and sine of x. I understand that this one's cubed, but that's okay. It's still sine of x. Great problem. Thanks for watching this. Study this a couple times. See you in class.